Fabulous. Thank you,
Woohoo.
Tiffany. My name is Kayla Viveros, and I am the supply chain manager with Polaris MEP. And today we are extremely fortunate to have Jeannie King here from NASA, and she's an innovation partnership specialist. So I can't wait to hear what that's about. Next slide, Jeannie. Perfect. One more. Awesome. Thank you. So most of you already know us. You're here, and we appreciate your time today. Polaris MEP is the manufacturing extension partnership within Rhode Island. Our job is to support all of our Rhode Island manufacturers with their top line, bottom line, and pipeline. This slide's really a special one for us. It kind of shows our economic impacts to our manufacturers after each project that we do with the manufacturer. 6 months to a year later, they're actually surveyed, and they put their own impacts, and that gets sent out to NIST, our National Institute of Standards and Technology. NIST federally funds all MEP centers, and we are one of 51 MEP centers nationwide, and those are separated by state border. Awesome. Jeannie, next slide.
So we ready for my part here?
Heck yeah, kicking it over.
So thank you so much for having me today. My name is Jeannie King. I actually work at the NASA Glenn Research Center in Cleveland, Ohio, in the Office of Integration and Partnership. And as Kayla introduced, I am a partnership innovation specialist. And so some of the work that I do is to introduce NASA across the country as a resource. So my strategic goals today are to introduce NASA as a resource. I seek to empower regions and universities by communicating the opportunities and providing knowledge to help you better learn how to interact with us, increase our presence and interactions in the region to hopefully grow proposals and collaborative opportunities, highlight some of the partnership opportunities and resources that we offer, guide collaborative potential by introducing our core competencies and speak to our priorities, lay groundwork for future activities, and then ensure that our science data is accessible for the greater good. So who is NASA? I think as many of you know, we are a research organization that really seeks to explore the universe and beyond. We are astronauts, as so many know, but then we're also scientists and researchers, engineers. But then we have a series of other professionals that include accountants and writers and really function as a full business with all sorts of expertise. So where is NASA? As you can see in this map, NASA has several centers around the outside of the United States, from California across the country to Washington, D.C. And then you can see NASA Glenn here in northern Ohio, and we kind of sit here by ourselves with the Neil A. Armstrong Test Facility just to our west. So speaking to a little bit of our mission, we drive research, technology, and systems to advance aviation. The first A in NASA is aeronautics. And then we seek to expand the human presence in the solar system and beyond. When you think about NASA, we are divided into these mission directorates. And I think this is important to understand because when you're looking to align with NASA, and you'll see some of the opportunities later in the presentation, these areas and these mission directorates really hone in on a specific expertise or a specific area. So our exploration systems development area is creating the steps, the path for Earth and back to the moon. Our space operations work is, again, going beyond low Earth orbit and speaks to the commercial launch services, International Space Station, space exploration. Science is a really great area for mission directorate because I really see that mission directorate as the building blocks of the future of space. There's a lot of basic research that happens there that really starts to create that base for space exploration. Space technologies, we're really looking at the technologies developed for space flight. And then aeronautics really is so much an area of just the development of aircraft and aircraft technologies and electrified aircraft and all in those areas. And again, this will become later on, I'm going to speak to the opportunities. And so, for instance, if you're not in the area of aeronautics, you're pretty much, that's not an area that you might not focus your initial attention when you're trying to seek opportunities that we have. So here's a little background on the NASA Glenn Research Center. As you can see, we are right there next to the Hopkins Airport in Cleveland, Ohio on 307 acres. We are half civil servant employees and half contract employees. We also, just to our west is the Neil Armstrong Test Facility. That's on 6,700 plus acres, 21 civil servants and 100 contractors. That is a test facility where we do a lot of basic tests out there. So when you talk to the core competencies of NASA Glenn, these are the areas where we focus a lot of our research and really where we have quite a bit of expertise. So aircraft and in-space propulsion are two different areas, and cryogenics, those are the those are two areas of expertise. We also have a huge area in power and energy storage and conversion. We have amazing expertise in materials and structures. And then we have communications, and then we have our biomedical area. That's a little bit of a smaller area, but we do have some expertise there in human research and performance. When we think about NASA as a resource, these are the general areas that we have that are available for interaction. So we have our research, development, and test services. We have our facilities test services. So as long as our facility that you're looking to engage is unique, and because we cannot compete with the outside industry, those are services that you can leverage. We have intellectual property, and we'll speak a little bit to that. We have a suite of patents that are available for licensing. And then we have subject matter expert services where there might be an opportunity to work with some of our expertise here. And we'll talk a little bit about how you make that happen. Here at NASA Glenn, here's some of the unique space environmental test facilities that are available for use. We have one of the largest vacuum chambers. We also have a vibration facility, and those are both at the Neil Armstrong Test Facility. We have an acoustic test facility that is also out at the Armstrong Test Facility. We have what we call Glenn's Extreme Environment Rig, which we call the Gear Lab, which simulates the surface of Venus in both gas composition and temperature. We have the zero gravity research, which we also call the Drop Tower, where we can simulate 4 to 5 seconds of zero gravity. And that's a nice test facility that we have available. We also have what we call the Slope Lab, and this is a moon simulant lab that we have at Glenn. We also have several unique aeronautics test facilities. And again, because they are unique, this offers the opportunity to work with us in these, should these be a facility that you might be seeking. We have the wind tunnels, propulsion lab, icing research. So this just gives you kind of an overview of some of those facilities we have, if that's an area where you're seeking to engage with us. So when it comes to working with NASA Glenn and really working with NASA overall, these are the primary areas or the primary ways that we have available for working with us. So we have our licensing, and I'll speak a little bit later about how you learn about the intellectual property that we have available. We also have a software catalog that's a free resource, and I'll introduce that to you as well. When it comes to working with our facilities or interacting with our subject matter experts, we engage with something called the Space Act Agreement, and I'll speak to that. We also have SBIR, so Small Business Innovation Research Awards, or our Tech Transfer Research Awards. And then we have some other early stage innovation and partnership programs. Again, I'll identify those in the end. So patent and patent licensing. A patent is, a novel, new, non-obvious technology. And we do a lot of fundamental research at Glenn. And one of the positions that I have is when that research, when the inventor feels that something has been created that is new, they're required to complete what we call a new technology report. Once those technology reports are submitted, they come to our tech transfer group and to our patent licensing team, where we review those and make decisions on whether we patent those or not. Once those are patented, that intellectual property is made available for licensing for the public. As tech transfer is a mandate, this just gives you a feel for some of the policies and acts that have been implemented over time by the government that require tech transfer from the federal labs. So as I mentioned, NASA develops disruptive technologies. Much of that work is published, but some of that work is patented. And through our office, we make those patents available for licensing. Our technology transfer expansion program, which we call T2X, focuses on engaging partners, very specifically entrepreneurs, to commercialize that technology. This just speaks a little bit more about kind of our office, where we reach out and make these programs available. So here's a look at the patent portfolio. NASA's patent portfolio is available through our tech transfer portal. Our patents are divided into these categories and made available through a search engine. Each technology is then summarized in this 2-page sheet, where we really take a deep dive or a look at why the technology was available, why the technology was invented, what the benefits are, and the envisioned applications. And those are then, you can kind of take a look through those and figure out what technologies might be of interest, and then apply for licensing those. NASA's licenses are available kind of in these 3 flavors. The evaluation license is a standard, what we call a test drive. It gives you the right to make, have made, and use, but not sell. So this is really an opportunity where it's a low cost, 1 year, renewable up to 3 years, minimum risk, kind of easy to engage opportunity to figure out if the technology functions the way that you want and solves the problem that you're seeking to solve. The next one is very similar to the evaluation license. It's a government use license, and these are available at no cost when they accompany a awarded government opportunity. So maybe if you've identified a technology in our patent portfolio that might accommodate a SBIR, if you indicate that, hey, I think this technology will work well, and you are awarded that SBIR opportunity, you can use this government use license to leverage the technology. Again, make, have made, and use, but not sell. And the duration is the same duration as the government opportunity that it accompanies. And then a commercial license is really a more custom opportunity. And that's when you really get into the ability to sell. But those are kind of negotiated and on an individual basis. But a great opportunity should you find that the technology really works in the way that you'd like it to. The NASA software is a free resource, and I think this is an amazing opportunity that we have. Again, the software is available through the portal or at software.nasa.gov, and it's divided into these categories. And as long as you fit, so the software you can request on an individual basis, and as long as you fit the category of who the target audience is, that can be shared with you. So we have anything from government use only, where you have to identify the government project that that would demonstrate that you need that software, all the way to open source opportunities. So we have a little bit of everything, but it's a great opportunity just to look through, and you can kind of browse that as you like to figure out if there are opportunities in there that you're interested in. This speaks to the Space Act Agreement. I mentioned it earlier. When you're seeking to engage with NASA, we have 2 flavors of Space Act Agreements, the reimbursable and the non-reimbursable. The reimbursable, where the partner pays for the work to be performed by NASA. The non-reimbursable is typically when NASA and the partner have they bring their own resources to the table, and they're both walking away with kind of a deliverable. So say we have a technology and, you need to leverage it for a particular reason, but we both have a takeaway that we want. That's a non-reimbursable. Those are less common, but there are opportunities. And in order to engage for a Space Act agreement, if there is reimbursable, there is an upfront payment. There has to be a very clear statement of work with milestones identified and agreed upon by both parties. There are no guarantees, as the subject matter experts or the facilities have to be available and approved for use for what you're looking for. And then I think it's important to know that inventions resulting from a Space Act agreement remain with the inventing party. So say you're working with NASA and you invent a piece on your end, or we invent a piece on our end, those stay with those individual parties. What's invented together is then the property of both parties. So it's just kind of a clarification that I think is important. So right here, this is a little bit about our small business innovation research programs and our STTR. So these are opportunities that open up. So the phase 1 SBIR is a 6-month, $150,000 opportunity. The phase 2 and then the phase 3, and these are kind of building block programs. NASA also introduced a NASA Ignite, which really is focused on the entrepreneurial community to help shape the aerospace market. So just kind of diving into some of these. This isn't necessarily my area of expertise, but we always like to introduce this as an opportunity to look in. These are nice funded opportunities should they align with your area of expertise. And then what success looks like. So we've talked a little bit about kind of what happens, and can you give us an example of opportunities where maybe somebody did leverage intellectual property or some of the programs. So NASA has a publication that they call spin-offs, and spin-offs are commercialization of NASA technology. So if you're familiar with memory foam originated at NASA as an energy absorption or a cushion. And memory foam has since been rolled into all sorts of terrestrial products, from shoes to pillows to beds. And so that's an example of a technology that has spun off into something else. And here are some others that are more common, including, baby formula stem from a NASA technology, the cell phone image technology, a lot of space communication. So here's just a flavor of some of those. In addition, through our technology transfer expansion program, we have what we call these pipeline opportunities. So I'll walk through these two examples because I think they'll give you an opportunity to take a look at what some of our success story looks like. So Wondrous is a company that was started by a professional athlete, Aaron Wallace, who was a NFL football player. And as a program that started from one of the centers, he participated in a professional sports association training camp where we introduced, very much in the same way where we are today, some of the programs and some of the licensing opportunities available. So following that program, Aaron decided to go into our FedTech program, which is a not-for-profit program that NASA and some of the other federal labs submit their technologies to. And then these entrepreneurs explore concepts like business model canvas development and using patents to solve everyday problems. And through his FedTech experience, Aaron ideated the use of a NASA multi-stage filtration system to be used for commercial air filtration. And so he worked in that program and he worked with those teams to develop, determine whether there was a customer base for it, and then develop products in that way, or develop his filtration system, and what was his target market. And then he went on to talk a little bit to his business development through NASA's Startup Feature Series, which is a series where the entrepreneurs talk to their experience in working with NASA. And then Aaron worked with our MEP here in Cleveland, Ohio, where they helped him develop a prototype and to figure out how his product would work and if it was feasible and kind of where the loopholes or where the hurdles were in his product development. So that's one pipeline story, and Aaron continues to press on and is seeking the opportunity to go to the next step and possibly explore a commercial license in that field. So then the Smart Tire Company was also participated in our FedTech Startup Studio. They licensed the Super Elastic tire, which was a tire originally developed for moon applications, and they have a partially exclusive license for a related technology called the SMA tubular structure, which is kind of a cross between the super elastic tire and a bike tire with a little bit of a different twist on the technology. And so they are seeking to develop that technology for bike tires and micromobility, but have also have a non-exclusive license and are seeking use of that for lunar terrain vehicle tire development. They also participated in our feature series under Startup NASA, and then they were on Shark Tank seeking that. They also have a Space Act agreement where they work closely with our inventor team to transfer that technology from us to them. This is also a really great story here. So Ozark Integrated Circuits has been working on NASA's integrated circuit chip technologies over many years. They've had government use licenses and research licenses. They've been awarded small business innovation research grants from not only NASA, but they have some other opportunities through DOD and some of that. And they've really made huge progress in the development of NASA Glen's silicon carbide integrated circuit chip technologies. So they're continuing to press on and have a commercial license for that. So, and I'm not going to speak to these specifically because, again, this is not necessarily my expertise, but going back to my original strategic goal in having webinars with some of these MEPs is to identify some of the opportunities that are available through our small business programs through NASA and through our office of, OSBP. And then I started off kind of speaking to this at the beginning, and so I'm going to wrap up with this, which is speaking a little bit to some of the opportunities that are available. So when I first started, and I've been with NASA in this stint for almost 8 years, when I worked with some of the partners, what I found was that there was no one-stop shop place for where a lot of these opportunities are available. And so some of the work that I did on my own was to really take a deep dive and do my best to understand what are some of the funded and unfunded opportunities, how can I consolidate them and then make them available for collaborators or possible collaborators to search through themselves so that they can find where they align best with some of the opportunities that we have available. So when I broke that down, I broke it down by mission directorate, and then I really started to just explore what are the opportunities. And so I put together these 2 slides. This slide is really focused on space technology mission directorate. That's where a lot of our academic focus programs are under space technology research grants, and SBIR actually falls under there as well. So does tech transfer. Now, even though tech transfer probably spans all of the mission directorates because we have patents from all of them, this is actually where we fall under the mission directorate structure. But you can see again in here under tech transfer, we have our T2X. So this type of outreach where we're connecting regions with our resources, our patents, our software. We have an open data portal where we have some of our data available. We have tech webinars, which I think are amazing opportunities where the inventors craft a presentation and then engage in question and answer on their specific technologies. We record those and then we make those available. And those are also available on the Tech Transfer portal. If you're looking to engage in the lunar surface innovation initiatives, there's some opportunities there. And so this just gives you a feel for what they are. And each one of these has a link behind them that takes you to the actual website where the details of those specific programs are identified. And then next to that, we had talked a little bit about Aerospace Research Mission Directorate. I will say we call it ARMD. If you are, if that is a field that you are focused on, that website was recently redone and they really did an excellent job providing just amazing information and background and direction on where we're headed. I would definitely spend some time in that on that website. The Science Mission Directorate, all of the Science Mission Directorate opportunities are available through ROSES, and all of the opportunities from across the all the funded opportunities are available on what we call NSpires. But you can get, it can be very overwhelming to jump in there because there's just so many. So I always kind of recommend that you start here and start to kind of navigate where you think your interests are to make sure that you end up in the right place. Just looking at, you know, pages and lists of opportunities might not be the best first step in trying to find where you might align. But again, then coming back over here, we get back into academic opportunities with internships and MIRUP and capstones and opportunities there. You know, those are all listed there. So I am Jeannie King. One of the other things that I'm trying to do through some of these engagements is introduce myself as a point of contact. So, you know, in addition to Polaris, if you have specific questions, and you can reach out to me directly, and then I can do my best to help you navigate or kind of answer your questions should you have them. And then of course, Kayla, this is her information to share. And that's my spiel. So if anyone has questions, please feel free to reach out.
I have a question for you. You had stated that there were kind of 3 licensing pathways for, you know, our manufacturers to be able to work with NASA. I think in a lot of cases, most people think that it's not cost effective, or maybe might have that in their head. Can you give us an idea of what an example of an expense would be on at least that first licensing pathway?
Yeah, sure. So the evaluation license is $2,500 for the year, renewable up to 3 years to license the technology. So, you know, that's a fairly low cost option. And again, the government use, should you align it with the award of a funded opportunity through the government, that's actually a free opportunity. So, and again, the timeline will be that of the award, the awarded, you know, grantor.
Awesome, thank you. And that being said, it's the use of the technology, but NASA doesn't actually create products, right? So you're getting
correct. Well, and so that's a good question, and I'll go one step further on that. Not only do we not we don't manufacture anything, I think it's really important to understand that these are base technologies. So the majority of our work, so fundamental research is really those base building blocks, and most of the work is designed for space applications, but they're what we call very low technology readiness levels, where some of these are just base technology seeking engagement with collaborators to develop it in a product that solves everyday technology. So oftentimes what we'll find is some of the technologies per se would work very well if embedded in some other product. So for example, like a materials, we have a huge portfolio of materials where we are seeking engagement in companies that are looking to develop the material, but at the same time having those interested or creating products from those materials is also just a business in itself. So a lot of our technologies will be like lightweight or high temperature or radiation hard or robust. That's really a core of kind of some of the work we do when you're talking about materials. So we work a lot in a material called shape memory alloy. So shape memory alloy is an elastic, highly capable, high performing metal are then, those can be rolled into other products. So, there's a lot of opportunities, but to say that to envision that you will license something and it will be just in need of someone to make it and sell it is not really where the licensing opportunities are for the most part. For the most part, the development of the technology is going to need research and development to create that solution to the problem that the company is seeking to solve, if that's good.
Awesome. Mr. Powell, you have a question?
Yeah, I have a question. Okay, can I ask a question? Hi, Jim. Thank you for the wonderful presentation. Really enlightening. I am a scientist and I was a faculty at Brown University in Rhode Island. I recently founded a company on the image processing, AI, signal processing, that domain. And I mean, there's a patent from Brown University that kind of we have an exclusive agreement. Now, happens to be, I started as a medical technology, but now I'm using, I have few NASA engineers in touch, like in a personal level. And I know some of the problems, like, for example, the moon landing team, I know a couple of engineers. We talk occasionally how this technology can benefit. Now, I mean, again, we're early startup phase, and now I'm confident that ever, and hopefully we should be able to communicate one-on-one to show some of the demonstrations of what I built, and then ideally I'll be looking for an SBA type of grant. It's a very generic technology to, clean noise from all sorts of data and reveal features from images, both from space images, like from the science part of it, but also for the technology part of it. So I will be looking forward to some kind of SBA type of engagement, and then where actually I can work with the engineers. I know some of the problems, but there is no funding for this. But these are like highly expensive, technology to build and execute. So I'll love to engage with you. And how do I do that? Actually, email you and look for an appointment with you.
So so did you tell me I can't hear overly well, but did you tell me you have licensed a piece of NASA technology? Is that what you said?
No. I invented something, and I'm building a technology on image processing that NASA can benefit from. There are some mutually interesting problems that I believe I have unique capabilities. And on a personal level, I ran it by some of the NASA engineers, particularly in the moon landing team. They really love it, but I'll be looking for a real engagement to actually demonstrate what it is capable of, and I believe that it will immensely benefit some of NASA's operations. And I would like somebody like you to really demonstrate and guide me to what kind of opportunities that I'll be suited for.
So it's I will say, being familiar with every opportunity is a challenge for any single person. But what I would love to do is share the dashboard where you can start to dive in there and take a look at where you might see the alignment. I think that's going to be your best opportunity there. In addition, as an academic institution, is that what you were telling me, that you work for the school?
Well, I used to. Right now, I founded a company. It's like a startup, basically. I work in the campus. Yeah, right now. So just a brand new startup, and then we are building.
That's where I would recommend you start. I would kind of dig into some of those opportunities and just take a look, and then reach out to me if if that works for you, and then we can see if there's more alignment. But you're going to know your alignment better than I'm going to know your alignment.
Yeah, of course. Yeah.
So I would recommend to start with the dashboard and then see where it goes from there. That would be my suggestion.
Okay, and dashboard, do you mind sharing that on the chat window so that we can have a look?
I'm sorry?
Do you mind sharing the dashboard on the chat window?
Yeah, the dashboard, That's actually another question in the chat was, is there the dashboard or a website that shows the technologies available for testing and transfer? And the answer to that is yes. Can you go back to that slide, Jeannie, just to
Yeah,
share
but
with them where
the
that is?
dashboard itself, I will tell you, I've been trying to figure out how to make this more openly available, but it is a project. So this just lives on my desktop. But I can share this. And Kayla, can I share this with you so you can share with the team at the end? Is that okay?
Yeah,
Actually,
absolutely.
okay,
Absolutely. And we actually have a general rule at Polaris MEP that we really want feedback for continuous improvement. So our team will send out a survey at the end just to give feedback for this. And once we receive your survey, we will send out the slides to you.
Oh, very good. But yeah, so I will send them through them to distribute. But yes, this just lives there. And I will provide this as like a caveat is I haven't tested every single one of these links. So I will try to do that before then, but that's kind of the concern in creating something like this is that if the link behind it changes, then you have kind of a mismatch. So, but I will definitely share this and you can really start to dive in. I think there is a lot here that you might find in alignment with your work.
Thank you.
I did just also put in the chat the link to the patent portfolio and software catalog. So if
Awesome, thank you.
if manufacturers do want to take a look into that and see if anything strikes your fancy, or you're interested, I mean, there are a lot in there, and sometimes it's just fun to kind of scroll through and see what may be useful to you. You can always reach out to Kayla or Jeannie, and then see how that technology could benefit you.
Yeah. And I will also say just technology.nasa.gov. That's just the full portal. And there's also webinars on there, and you'll get a feel for some of the other success stories. You can access spinoffs, so you could really dive into the real stories of some of those technologies that were developed for space that rolled into something else. So there's a lot there that that you might find of interest to better understand how others have worked with NASA.
Are there any other questions? Feel free to unmute. No? Well, fabulous. This is just one of several different webinars that we are going to be doing with Jeannie and NASA. Polaris MEP has a Space Act agreement in place, which allows us to have this partnership and bring these technologies kind of to the forefront and educate our manufacturers in Rhode Island on, ultimately how to be able to utilize and work with NASA. So we're very excited. We do have an in-person event coming up here in the next couple of months as well. So if you have any other questions, we'll stay here for a minute to answer them. And if not, thank you so much for joining us today. We ended a little bit early, but fabulous. Get some time back.